Hi, welcome to my Physics Lesson 1 video. I'll be uploading a series of videos that educate you on physics and its topics. This is the intro to physics lesson, and now let's get into it. Okay, now let's do the essential questions. Now, if you're a beginner in physics and have questions related to these, watch this video because this is exactly what it is about. Now, let's get on to the questions. Well, first question, what is physics? Well, physics is the study of nature, and it helps scientists learn concepts like motion, forces, and etc. that occur naturally in nature. Okay, let's go to question 2. What does it help us do? Well, it helps us learn more about the concepts like motion and forces. As you learn more and more equations, formulas, and stuff, as you'll see soon in this video. So let's see, number 3. What is motion? Well, motion is the movement of an object. If a force reacts on it, it can be a contact or non-contact force. So, to say in simple words, it's just when an object is affected by any force which results in the object moving. Okay, next question. 4. What are forces and what are some types of forces? Okay, so let's see. Forces are the interaction where the object is not resisting the force since it's causing the movement. An example of this is gravity. When you jump up, the gravity pulls you down since you come back to the ground. Since you can't resist gravity, it always pulls you down. If you have an acceleration greater than 9.8 meters per second, then you can escape gravity because that's the escape velocity that you need. You'll learn more about that soon. Okay, so next question. What are some ways to calculate the amount of forces in an object? Oh, sorry. What are some types of forces? Okay, so some types of forces are contact and non-contact, as I said before, but non-contact forces have more subsections within them, like gravity, and contact have the same subsections within them, like friction. Well, you might be thinking what non-contact means and contact means. Well, non-contact means when a force is acting on an object without touching it, like gravity does that, like when you jump. And contact force is when a force is acting on an object by touching it. It's like when you slide something across a rough surface and it stops because of friction. Okay, next question. What are some ways to calculate the amount of force in an object? Well, I just don't want to give it away, but you can calculate forces by an equation named F is equal to m times a, where m is the mass. M is the mass, and a is the acceleration. It can be due to gravity or it can be anywhere. So then you get the amount of forces, which is measured in newtons, which is named after the person who learned more about physics and started to discover about the acceleration due to gravity, who was Isaac Newton. Okay, so this is the wise word wall. It's really hard to say, and this you'll see repeatedly throughout the lesson, and introducing you to new vocab words like these 3 right here, which are really important. So the first word, velocity, you probably heard of it, probably maybe not, but you probably heard of it, and you probably didn't know what it is. And this is the definition. So it is a unit that describes speed of an object, but with a direction and a magnitude, which is a vector quantity, which you'll learn about soon. So there's a misconception that velocity is the same as speed, but speed is not a vector unit. It's a scalar, which you'll also learn about. So they're not the same, since velocity gives us direction and magnitude, while speed gives us only magnitude. So speed can't be negative, while velocity can be negative. Okay, so the next vocab word is acceleration. So acceleration is the unit that describes the change in velocity. The velocity depends on this acceleration. So for example, I had my velocity at 0 meters per second, and the acceleration is 1 meters per second squared. That's the unit. So in just 1 second, that 0 is going to go to 1, and in 2 it's going to keep increasing. It's not constant. It doesn't go to 2, but it goes to 3, since it's seconds squared. It's meters per second per second. So these are the main two quantities. So if there's 0 acceleration, that means there's constant velocity. So if the acceleration 0 meter per second squared, and the velocity is also 0 meters per second, then the velocity does not change throughout the entire whatever the question or the background is. So if the velocity is 0, there's no acceleration. Not 0, but none. Okay. So the next vocab word is time. Well, time is easy because it's just time. It is a unit which represents amount of time elapsed in seconds, minutes, or hours, and etc. So you can represent this in years, decades, or even centuries, but it just represents a value for the amount of time elapsed. Like in meters per second, it says the object traveled 0 meters over that many seconds. So if you wanted to say the object traveled 5 meters in like 1 second, that's the velocity, 0 meters per second. If you wanted to say the object traveled 10 meters in 10 seconds, then that means if you simplify that fraction, 10 over 10, so 10 and 10 cancel out, so you get 1 meters per second. So that's it. This is the wise word wall. So it's really hard to say. Okay, so this is the types of values and quantities. So there's 2 types of quantities, as I maybe hinted on you before. The 2 quantities are vectors and scalars. So vectors are quantities which represent you using both a direction and a magnitude or length. So an example of vectors can be like 5 meters per second north, which is the velocity, which velocity is a vector component, and it needs a direction to be considered a vector. If you say 5 meters per second only, that would be speed, not velocity. And the 6 kilometers south, that would be displacement, because it has 6 kilometers south. If it was negative 6 kilometers south, it would still be displacement. And without the south, instead of displacement, it would be considered as distance. So vectors can be drawn as like lines, which are also called vectors. So in that line, the angle represents as a direction. And as an example, in here it says 5 meters per second at 50 degrees northeast, which is a direction. So this makes a vector line. Now, scalars are way different than vector quantities. A scalar quantity represents a value with no direction, but it can only have a magnitude, but it cannot be a negative value. So for example, do you see those speedometers in your cars and other vehicles? That shows speed, which is always positive. Even if you go reverse, it's always positive. So speed is a scalar component, which means that it doesn't have a direction, only a magnitude, which is only positive too. So as I said in the vector section, it's considered speed when it doesn't have direction, but only magnitude. Like here, it has 5 miles per hour. That's it. So no direction, only magnitude. And the other example is 10 kilometers. So instead of 6 kilometers south, it's 10 kilometers only, without the south or any direction, which makes us distance, not displacement. And then it's 5 seconds. Well, time can't be a vector component since it doesn't have a direction. So time is always a scalar component. And that's another example of time can be an hour and etc. So these all have only magnitude and no direction, as you can see. Okay, now let's go on to the next topic. Okay, now let's talk about vectors. So with vectors you can do two things, adding them and subtracting them. So let's go over adding first, since subtracting needs for you to know how to add. So for adding vectors, there's 4 steps. First, you have to draw the vectors based on whatever your expression in the magnitude and the direction of the vectors you get. Then you have to connect the first vector's head to the second vector's tail, and then maintain the same magnitude and the direction. You can try to do that, but it should be accurate, not like exactly. If you can do it exactly. And then step 3 is to draw a line from the tail to the head. And then step 4 is to add the values. Okay, so let me summarize that in my own words. So you first have to write the expression like here, a plus b. So then draw out the vectors like these two. A points north and b points east with a specific magnitude. Then draw the a vector and then connect the b vector to the head of the a vector pointing outward, meaning that the arrow of the b vector is pointing away from the arrow of the a vector. Then the last step, you have to draw a line from the bottom of the a vector, from the dot, the point where the vector starts for vector a, and then you have to draw a diagonal line, as in this example, to connect it to the head of the b vector. So that creates another vector. You can name it as c, or a plus b is equal to c. So if a was 1 and then b was also 1, so c would be 2, since 1 plus 1 is 2. And if you have a specific triangle like this created, it's a right triangle. If the a was 5 and then if a was 5 and then b was 10, to find a plus b, instead of adding them, you have to use the Pythagorean theorem, which is just vectors a's magnitude square plus vector b's magnitude square, and is equal to the vector a plus b squared. So that's just 5 squared plus 10 squared equals c squared. That's what I'll name it in this example. So when you get that, you get c as 25 plus 100. You get 125, so square root of 125. You can simplify that by saying you can say that as 5 root 5. So you can say that a plus b is equal to 5 root 5. So that's an example, and that's it for adding vectors. So for subtracting vectors, there's also 4 steps. So I'll give you an example related to the other example after I talk about these 4 steps. So for the first step, you have to subtract the vectors, write out the expression like you did for adding them right here, and then you have to draw the vectors. It's kind of the same as adding the vectors, but it only has one extra step. And then you have to also draw the vectors like here, right there. So then you have to reverse the vector that has a negative in front of it. Like here, instead of positive b, it's negative b. So you change this positive b right here to a negative b, which is the opposite direction but the same magnitude. The direction only changes to the opposite direction. It's the same if you have as this is the positive, the negative would be downward, but opposite. The magnitude wouldn't change. So then, and then you have to add them. So just follow the adding steps, which is you have to draw the a vector, then connect the tail of the b vector to the head of the a vector, and then keep the direction the same, and then just draw a diagonal line from the tail of the a vector to the head of the b vector, which you can name as c vector or a minus b vector. So you can use the Pythagorean theorem for this too, but it depends on what triangle it makes. So if it makes a right triangle, you can use the Pythagorean theorem, but if it makes something like, so if it talks about something like this, that's A, and then that's B, you do the same thing by connecting them, and then you add them. So if this was 1 and this was 3, the resultant would, that's what it's called, the resultant vector, that would be 4. So you just add them. But for right triangles, you have to use the Pythagorean theorem and do it. Okay, well that's it for this video. So see you in the next video, and hope you learned a lot about physics. See you later.